We have a trig equation to solve between 0 and 360. Unfortunately, there's a square root in there. So the first thing to do is to get rid of that square root. And I'm going to need to, well, the best option I think is to write it as minus 1 minus a half sine 2x. Okay, get them on different sides and then square them. If you square them as they are, you're going to get these cross terms where you have this times cos x. You don't want that, so basically get it on opposite sides and then square. So we get cos squared x equals, and then the negative times the negative just disappears, so it's 1 minus a half sine 2x. Now the only thing we need to be careful of is that when you square something, you can introduce extra solutions. So it's worth writing at this point, check spurious solutions at the end. I'll give you two examples of where this can come from. First of all, if you take the trivial case x equals 2, when you square it, you'll get x squared equals 4. If you then solve this, you'll get x equals plus or minus 2. But there's clearly only one solution to this. The minus 2 has arisen when we square it because both of these numbers have the same square, minus 2 and 2, but actually they're not the same number. This can happen in the case of like the graphs. So you might have a graph that, I don't know, let's just make it constant, and then some other one that maybe it goes a bit like this. So you've got this point of intersection. Now, if you square them both, they kind of move around. But basically, this might be like k, and this might be minus k. And when you square it, this will suddenly become positive, and they'll end up being in the same place. So that's like a geometric explanation of why you get spurious solutions. They might solve this new equation, but not necessarily the original. Just something to be aware of whenever you square equations. Okay, so what next? Well, we have, okay, let's just take this step by step. I'll leave the cos squared for the moment. I've got that sine 2x is 2 sine x cos x. That's a double angle formula. So we can write sine x cos x. Now at the moment, this isn't like it's kind of a quadratic, but we've got a sine there, we've got a cos there, oh, we've got a constant, that's not great. But actually, you can see if I'm just going to move this over, sine x cos x, well not move over, but get it, rearrange the equation. So sine x cos x is going to equal 1 minus cos squared x. And this is good news because 1 minus cos squared x is sine squared x. So I'm just sort of taking it bit by bit and manipulating it. Now this is much better because we don't have that 1 in there. In fact, we just have a common factor of sine x now, which we didn't have before because of the 1. So I'm going to now subtract sine squared x from both sides and factorize it out. Okay, and we're well on our way to be able to solve this. You could have divided through by sine x, but if you divide through by sine x, you still need to think of when sine x is equal to 0, because those are our solutions. Sine x equals 0, or sine x equals cos x. And if you divide through by cos x, you get that tan x is equal to 1. So we need to deal with these two different cases, basically. Okay. Let's draw sine x to start with. Now, where is sine x equal to 0? It's when x is equal to 0, or 180 degrees, we're working in degrees here, or 360. Okay, so 3 solutions. We'll come back to that in a bit. For tan x equals 1, we're going to get a value here, and actually it's x equals 45 degrees. That's when you need to know your exact trig values, or add 180 because that tan is periodic about 180, so it's also 225 degrees. Right, are we done? No, not quite. Now we need to check. So even though these are solutions that solve the equation when we squared it, we need to check that it is a solution to the original. So let's check it out and see. Okay, let's deal with the ones on the left to start with. So x equals 0. That will give us cos of 0, which is 1, plus the square root of 1 minus half sine of 0, or sine of 0 is just 0. There's no way this is going to equal 0 because I'm adding, it's going to be 2 in fact. So no, reject. X equals 180 is the next one. Now cos of 180 is here, it's actually minus 1. So minus 1 plus the square root of 1. Now sine of 360 is 0 again, so this time it's minus 1 plus 1, it is 0. This is okay. X equals 360. Now we get cos of 360, that's back to being 1. And we are back to adding the root of 1 because sine of 720 is also 0. So this is not equal to 0. Reject. So actually we've got a lot of spurious solutions arising. X equals 45 now. Yeah, I'll do this one in blue because it goes with the up there. Okay, so cos of 45 is 1 over root 2. Just another one to know. Plus the square root of 1 minus a half of sine 90. Well, sine 90 is actually just 1. I'm just going to draw it here. Here is sine 90. So this is not going to equal 0. This would be 1 over root 2 plus 1 over root 2, in fact. So reject. Well, 4 solutions, only 1 actually was a real solution, an actual solution. Okay, what about the fifth one? X equals 225. Now we've got cos of 225. If you look at the symmetry, you see that it's just going to be the same as like this one here if you went 45 degrees to the left of 180, which is just the negative, so it's minus 1 over root 2, basically is what I'm trying to say. Make sure you can, as well as learning 30, 45, 60, 90 and 0, learn how you can get ones like this as well. And then I'm plussing 1 minus, and it's going to be sine of 450. Now if we subtract 360 we get 90, so it's again 1 minus a half sine 90, which is just 1 minus a half, which is 0, because this is going to be 1 over root 2, so this is okay. So the solutions are x equals 180 degrees or 225 degrees. Okay, good job.